This is Sunday, September 28th. I thought before Tuesday I would give you one more piece of information here before we measure, and I still haven't measured my amplifier, its response. Thought I would show you something you can do to model or simulate a circuit. If you remember now I'm confused on the numbers. Let's see, we're on 1, 2, 3. Number 2, when we did the Wenzel transistor F sub T fixture, he gave us a LTSpice simulation, and I believe I showed that. And I thought, I've never used LTSpice except at one time, and I'm a big user of Spice, but I use NGSpice under Linux. So I thought I would try this out. I'd already downloaded it for the transistor fixture. So what you do is go do a search for LTSpice download, and it'll get you to this page done by Analog Devices, www.analog.com/en for English, resources, design tools and calculators, LTSpice-simulator.html. The rest of that you don't need. And there are 2 versions you can download. Download for Windows 10, and I think it'll work under Windows 11. It doesn't make any sense. And you can even, if you're running Windows XP or older versions of Mac OS, but anyway, there's 2 versions here, one for Windows, one for Mac. And what I do is I just download the Windows version, and I run it under Wine, which is, it's just a replacement for Windows. And here it is up and running. And what I did is I took the audio amplifier from EMRFD figure 1.17 and built it from using the graphical interface here. And it's pretty straightforward, except if you're new, and there's no books that I know of. There are plenty. I think I have 38 books on Spice and internals, but I don't see any complete books on LTSpice. So there's a lot of tutorials. The page where you download the software, there are a number of tutorials, and a number of them on YouTube. So you just go and say you want a resistor. You go up here, click on resistor, and it'll bring you one. Put it wherever you want. Right click to quit, because it'll just, once you put one resistor down, it'll ask you if you want to do another one, etc. And since I've already done 11 resistors over here for the circuit, it automatically numbers a new one for me. To get rid of it, I just click on it and then hit the escape key. It gives me a pair of scissors and get rid of it. Now let me show you the one transistor here. There is a PNP. But I don't want to cut it. There's a PNP here, which is a 3906. So you go up here to this little, what is that, an OR gate. Click on it. It comes up with a select component symbol. Go down here, and there's a list of things down here. And here is an NPN, and over here is a PNP. So you do a PNP, and there's the symbol. And you say, OK, and it gives you one to put here. Now, before you put it, if you do a Control R, it'll rotate it. Now, let me put it back where it was. The symbol I want has the emitter at the top, but there's not one that automatically comes with the software. So in order to do this, and I had to think about this, do a Control R, now do a Control E, which will mirror it about the vertical. There's no mirror about the horizontal, so do a Control E. Now I've got the emitter in the right order, and then do a Control R for rotate. Now I got it in the position, and I place it wherever I want, and I'm done. So that's how I got that. Also, if you, excuse me, I'm getting hoarse. If you double click on some, whoops, I thought I could do this. There's a, let me go back here, see. Let me go do the PNP again. Put it here. If I double click on it, here it is. I did a right click on it. Let's see if I do it one time. If I do it one right click, it says, okay, pick a new transistor. And now you've got these models for PNP. And it's a 3906, it's common. So you pick it, and it gives you all the parameters for the model, which you're going to have to become an expert on. So do OK, and now I've got a 3906. So when I go to simulate, it'll use the right parameters and get you the right results. I did the same thing for the NPNs. I put in the 3904. If you don't have a 3904, you got two N2222s, then substitute a two N222222 for all three of these and try it with that and see what happens to the circuit. Now I added one thing here. I put a load. I put an 8 ohm load here for a speaker, and I'm ready to simulate this now. I'll let you go through the tutorials. I'm going to have a sine wave of amplitude 10 millivolts at 700 hertz, but I can also do an AC analysis from 200 hertz to 20 kilohertz with 50 points for every decade. So I got it set up to run. You go over here where there's a running man, and you left click on it, and it will run it. Then it gives you a graph here to plot whatever the signal is. So let's plot, and it starts at, doesn't show here, but this starts at 200. There's 1 decade there, there's 1 kilohertz, 10 kilohertz, and this point right here is 20 kilohertz. So let's look at our input signal. You put a probe right here at this point, left click on it, and it shows you that my signal is at minus 40 dB in green. And it shows you at the top here that this is voltage at node 06. It's at node 6 because I had already done a bunch of stuff before I put that in there. Now I want to go over here and look at the output. So I right click on it, left click, and now it shows me the output voltage out, which is this blue line here, and the bottom line shows me the phase. On the right hand side, it'll show you the phase angle, and it shows that it's, for most of the way, it's 180 degrees out of phase with my input signal, which is usually what happens in an amplifier, especially, well, a single transistor, but the way this one's set up, that's what happens here. And you can see that up to about 600, the signal goes up, and that's because of this capacitor here, and then flattens out. And what the nice part of this is, from about 700 hertz out to 20 kilohertz. It's flat, almost like a LM386. So that's what we should get from measuring the output with a load on the amplifier and a 10 millivolt signal in. So this is just a short video to show you that we can use LTSpice to simulate some of the simplest, well, you can simulate anything with it, but you probably don't want to do that with, we're not going to simulate an entire Autocraft KX3 or anything else. We just do their simple stuff. What else can I add about this? Oh, now I'm not a fan of this format of the graphics, and I'm going to do schematics another way because you've got to get some practice in here. I could go and make this base of this 3906, the Q4 level with the collector of Q1, but I'd have to shift a whole bunch of stuff around. Don't want to mess with it. So that's the lesson for today, and I'll be back on Tuesday. Thank you. And the usual requests apply.